Hey everyone, welcome to homework 4.10. So today we looked at being able to find the zeros or the x-intercepts using a quadratic function in factored form. We can also see the y-intercept when we look at it in standard form. So I'm going to go through the homework problems first, and then I'm going to go back and do some of the classwork problems at the end. Please make sure that you complete whatever classwork you did not finish in class because it is a very important part of your grade. And it gives you a really good practice. So a quadratic function is defined as such. Without graphing, identify the x-intercepts of the graph of f. So to find them, we can set each one of these to 0, because when one of those is 0, that means y is 0, and so that's where it will cross the x-axis. So x minus 7 equals 0. Then we would add 7 to both sides, and we would get x equals 7. So that's one place where x equals 7 and y equals 0. And then x plus 3 equals 0. Subtract 3 from both sides, we would get x equals negative 3. And so the other x-intercept, or 0, is negative 3 comma 0, because again, that's where y would equal 0. If we were to plug negative 3 in here, this would become 0, and anything times that then would be 0. Same thing if I put 7 in here. 7 minus 7 is 0. 0 times anything else is going to be 0 because of our 0 property. And so that would mean that our y value is 0 there. Now it says expand and use the expanded form to identify the y-intercept of the graph of f. So let's go ahead and make this our standard form by using FOIL or the box method, whatever you are most comfortable with. So you can go ahead and go x squared minus 7x plus 3x minus 21 gives us x squared minus 4x minus 21. Or if you need help visually seeing this as x minus 7, remember to keep that sign with it. We've got x squared, negative 7x, positive 3x, and negative 21. We end up with the same answer. So this means then that our y-intercept is negative 21. So 0, comma, negative 21 is where our y-intercept is. And make sure when it asks for the intercepts that you write them as points, because it'll also make sure that you've done it correctly and checking to see that when it's an x-intercept, we are not moving off of the x-axis, and so there's no value for y other than 0. And then similarly, when, right, so for example, this would be, we're looking at the y-intercept, we're looking at where does it cross the y-axis, and therefore where is x 0. What are the x-intercepts of the graph of the function defined by x minus 2 and 2x plus 1? So once, let's go ahead and say x minus 2 equals 0, 2x plus 1 equals 0. So x equals 2, that's one of them, so 2 comma 0. And then this one would be subtract 1 from both sides. We get 2x equals negative 1, divide by 2, x equals negative 1/2. So the other one would be negative 1/2 comma 0. So that leads us to see that it is B. Here is a graph that represents a quadratic function. Which expression could define the function? So looking at this, I see that I have an x-intercept of 3 and 3 comma 0 and an x-intercept of negative 1 comma 0. So the opposite would be x plus 1 times x minus 3. Because 3 minus 3 would give us 0, and this is a positive 3. Negative 1 plus 1 gives us 0. This is a negative 1. Okay, so the best possible answer here then would be x plus 1 times x minus 3, which gives us C right here. You may also want to consider that this has a y-intercept of, it looks like negative 2, negative 3. And if we were to put this into standard form, we would get x squared minus 3x plus 1x minus 3. You can see here that the constant is negative 3, and so that also aligns with our y-intercept. Number 4, what is the y-intercept of the graph? So we know that the constant here is 4, and so our y-intercept would be 0 comma 4. Because if we were to plug in 0 for x here, right, we would get y equals 4. And so that's you can memorize that that constant is your y-intercept, but you can also reason it out by saying, well, if I plug in 0 for x, and that's when I have a y-intercept, I'd be left with 4. An equivalent way to write this equation is x minus 4 times x minus 1. What are the x-intercepts? So again, we're going to set each one of these to 0. So x minus 4 equals 0, therefore x equals 4. So 4 comma 0 is one of the x-intercepts. X minus 1 equals 0, x equals 1 then. So 1 comma 0 is our other x-intercept. Noah said that if we graph this equation, the x-intercepts will be 1 comma 0 and negative 6 comma 0. Explain how you can determine without graphing whether Noah is correct. Well, we can plug 1 in, and we get 1 minus 1 times 1 plus 6. This one honestly doesn't matter because we're going to get 0 times 7, which is 0. So we know that this one works out because we have a y value of 0, and it is correct. We do negative 6 minus 1 times negative 6 plus 6. Similarly, this will be 0, and so we will end up with an answer of 0. So that works. So you can show your work and prove that, and you can explain if I plug in the values, I get y equals the x values. I get y equals 0, so I know these are x-intercepts. All right, sorry, that's very difficult to read and messy, but hopefully if you're listening, you can hear it. Okay, a company sells a video game if the price of the game in dollars is P. The company estimates that it will sell 20,000 minus 500 P games. So this is a revenue question. This is a review. Which expressions represent the revenue? So it's P dollars times the number of games that they can sell. So we would want to see it written something like that, being multiplied by it. And so our best option is going to be D, where we see that P is being P, the number, the game, the price, is going to be multiplied times the number of games we can sell. Write each quadratic expression in standard form. Draw a diagram if needed. So here we're just doing your FOIL method or your box. You can use whichever one you want. You can do a separate piece of paper if you need to. We're going to get x squared minus 6x minus 3x plus 18. All right, now let me show you with this one because we do have a lot of negative signs, right? X times x is x squared. X times negative 3 is negative 3x. X times negative 3 is negative 3x. And, oh, whoops, I wrote, see, no, look, I didn't write 6, too bad. Let's fix that, okay, so something's wrong here. All right, negative 6x, and then negative 6 times a negative 3 is a positive 18. Now I can combine my like terms, same as I would here, and we're going to get x squared minus 9x plus 18 is my answer. So, for the second one, I'm going to help you with that, and then C and D, I want you to do completely on your own. You can do these on your own. You do not need my help, and it'll be good practice to make sure you know how to do it by yourself. If you need help, you can text me and check, is this right? So I want to note that because this whole thing is squared, it's the same thing as multiplying x minus 4 times x minus 4. This is going to give us x squared minus 4x plus 16. Or x squared minus 8x plus 16. Okay, you can use your square method as well, but I wanted you to see mostly that x minus 4, all in parentheses squared, is going to be x minus 4 times x minus 4. All right, number 8. Consider the expression. Is the expression equivalent to x squared plus x plus 30? Explain how you know. So let's go ahead and work this out. We're going to do the first one, 30. We're going to do the outer, minus 5x. We're going to do the inner, plus 6x. And then the last, minus x squared. Okay. So, no, this expression is not equivalent, right? We end up with 30 plus x minus x squared. So it's not equivalent because we have a minus in front of the x squared. And so you can show your work here and say when we apply the distributive property. Negative x times x equals negative x squared versus this positive x squared. It says, is the expression 30 plus x minus x squared in standard form? Explain how you know. So yes, excuse me, because we see the squared term, right? We see that x squared. But you also could rewrite this, right? Because generally we would like our highest exponent to be first. So remember, the negative sign stays with the number it's in front of. So this would be negative x squared plus x plus 30. All right, number 9. Here are graphs of the functions. So you can see immediately this is a review of what kind of functions. Well, we can see that we have the x in the exponent. So this is a review of exponential functions. Which graph corresponds to f and which graph corresponds to g? Well, a is decreasing slower, so we would want to see a higher factor because more of it is being retained. So a is f of x, and b, which is decreasing more rapidly, has less remaining, and so b is g of x. And then it says explain how you know, so you would say right here, make sure you write an explanation. You're going to say exactly what I just said, right? That A is decreasing at a slower rate than B, or you could say B is increasing at a faster rate. And so we're looking at a factor that is greater for A because it's retaining more in this decay scenario. All right, number 10. Here are graphs of two functions. An equation defining f is f of x equals 100 times 2 to the power of x. Which of these could be an equation defining the function g? So notice that g is growing faster than f because it starts to reach a point where it's going to be overpowering that. And the curve is steeper. However, it is starting lower. So our starting value should be less. That helps us to eliminate c and d. And then it should be growing faster than times 2. So that leaves us with A because G has 1.5, which is going to be less than 2 and therefore not faster. So it would be a lower slope, right? It would never quite hit that one. But because it is going to eventually hit this f of x, we would need a factor that is going to be greater and therefore help us to increase faster and eventually catch up to f, even though we're starting at a lower point. Okay? All right. Your code word for today is ink. Ink is your code word, so put that at the top of your paper. And then if you'd like to stop here, you can, but I'm going to go ahead and go back to this part of the classwork to make sure you get a little bit more help with it. And if you need any additional help, you can definitely reach out. So first, it's asking you to find the standard form and then find the y and x intercepts. So finding standard form will help us to find the y-intercept, and looking at it in factored form will help us to find the x-intercepts. So I'm going to go ahead and FOIL this. So we're going to get 4x squared, and then we'll get minus 12x, minus 15x, and then last plus 15. So immediately before I even consolidate this, and I do want you to consolidate that, okay, 27x plus 15, this is my y-intercept. So the y-intercept is 0, 15. And then the x-intercept is when we set each part of the factor to 0. So this would be 4x minus 5 equals 0. So that would be x equals 5 over 4. Add 5 on both sides, divide by 4. So one of our x-intercepts is 5 over 4, 0. You can also put that in decimal form if you want. And then this one's a lot more obvious. X minus 3 equals 0, x equals 3. So the other one is 3, 0. Those are your x-intercepts. Okay? So that's what you're going to go through and do for each one of these. So whichever one is easier for you to do first, you can do first. We'll do 4x squared minus 16x minus 4x plus 16. Automatically we see that y-intercept is going to be 0, 16. And do label these in some fashion to make it easy to see. And then we're going to solve for x here. So 1 would make this 0. 4x minus 4 equals 0. Add 4 on both sides and divide by 4. X equals 1. And then here x minus 4 equals 0. X equals 4. So our two x-intercepts are 1, 0 and 4, 0. Okay. So you're going to go through and continue with each of these. If you can use foils, so you can do first, outer, inner, last, or you can also, if it's helpful for you to do it, you can use your box method. You can use the square and multiply them that way to make sure you multiply each one. The thing that I will suggest is that you make sure you're careful with all of your signs. And let me reiterate that you are expected to do all of these. So please make sure that you complete all of them before tomorrow. All right, if you have any questions, again, you know how to reach out. Happy homeworking and see you tomorrow.